Actor components are something that I feel gets overlooked a lot when you're starting out with Unreal. As you build out your games, projects grow in complexity, and actor components can be able to help build your systems so that you're not constantly copying and pasting and repeating code. My name's Neil with Crustaceous Studios, and today we're going to take a look at actor components, which not only help you organize and manage your project better, but help you build systems that lay the foundation of your game. Let's dive on in. So here we are in a clean first-person template project. So in order to be able to show off actor components, I think what we're going to do today is build a health system, because this can be able to show us all the different versatility that actor components can provide. But before we do that, we just need to do a few things here first. So we're going to set up a projectile system that when we click a button, a projectile will spawn. When it collides with an actor, it'll remove health, and then once that health reaches 0, we're just going to destroy the actor. So we're going to keep it very simple. So the first thing we're going to do here is under our content folder, I'm going to create a new folder. I'm going to call it Blueprints. And then under Blueprints, I'm going to create another new folder. I'm going to say Actor Components. And then I'm also going to create a new folder, and I'm just going to call this Projectile. So the first thing we're going to do, we're going to open up that projectile folder. We're going to create a new blueprint class. We're going to create an actor blueprint. I'm just going to call this BP underscore parent projectile parent. Base or parent works fine, whichever is going to help you know that this is what we're going to build our projectiles off. So we'll open this up and we'll dock that in here. So when you take a look at your blueprint, you're going to see all of these different things here. You have your event graph, construction script, and viewport. Your viewport is going to be where you're going to see all of your meshes, any type of collision, things like that. But the important thing to notice on the left side here are going to be all of your components. So this is where you're going to see things like, for instance, we want to add a static mesh. We'll be able to see, we'll get our widget in order to be able to control our static mesh. So I'm just going to start off, I'm going to call this projectile mesh. And if we add something, for instance, let's do a sphere, you can see we have our sphere here. Whenever you open up a character blueprint, so if we take a look here, we come to content, we look at first person, we look at blueprints in this first person blueprint character, we can see it has all of these components on the side. We have our capsule collision, an arrow, we have a skeletal mesh, then we have a first person skeletal mesh because the two different meshes. We don't have to worry about that right now. It's mainly for first person, and we have our camera, and then we have this character movement component. Now this character movement component controls all of our different values that help us move. Things like our acceleration, how fast we slow down, our half height when we're crouched, our speed, our max walk speed, our jump velocity, so how high we jump. So these are all components that come pre-packaged inside of Unreal, so you don't have to build these. And the same thing goes with our projectile. I'm just going to delete that arrow. So if I come here and I say projectile component, movement component, this is going to house everything that is needed for our projectile. So we can set our initial speed, our max speed. So let's say, let's set our initial speed to, we'll say 50, and we'll set our max speed also to 50. And then we'll turn our gravity down to 0. So that means that it won't fall over time. So if I hit compile, save, and I come back to our projectile component and I place it in the world here, and I raise it up and I hit play, we can see that it's moving. So that's without having to set up any code because it's all baked into that component. So that's understanding what components are. So we want to be able to keep this. Let's bump this up to, let's say 500. And then I'm going to scale this down. We'll lock this. I'll scale this down to 0.5. We'll do 0.25. Let's bump this up to 1,000. So this is really simple. Boom. We can see that it's moving. It's still kind of moving slow, but you know what? That's okay for now. We don't need it to be going any faster. So in order to be able to get this to work, we're going to need to add a couple of things here, because right now, if we just simulate this, this is just going through. You can see it fly on off, so it's not actually colliding with anything. So let's go ahead and add a sphere collision. We'll just call this collision so that way we can be able to better identify it. And then what we want to do is, instead of putting this as a parent to the projectile mesh, we'll drop this on the default scene root and make that the parent. And it's going to look really big here, so let's go ahead and scale this back up. Let's do one. One's a little big. We'll do 0.5. Yeah, 0.5 seems fine. And then we can just scale this down. And I'll scale everything down because it's a parent. We'll try that for right now. See how that looks in the world. Yeah, that'll do. Okay, so if we simulate, it's still going to go through the wall. So before we can be able to enable any of this, we need to create some things first. So since this is the default root of the component, we're going to want to make sure that our collision is set up correctly. So the first thing we'll say is block all dynamic. And that means that if we simulate this, we're going to see it's just going to stop when it hits the wall. Perfect, which is what we want. Just to be doubly safe, we'll turn off this projectile mesh. We'll just say no collision, because it's just there for just looks. We just want to visually see it. All the collisions happening off of this. And then from here, when we're on the collision, if we come down to on component hit is what we want. When we have that, all we're going to do is we're just going to say destroy actor. And that just means as soon as it hits this wall, it's going to disappear. And we'll see that here if we simulate. Boom, disappears. Perfect. So we know that all of this logic is working. And if we just want to be doubly sure, we can say print string. We'll just say destroyed. We can see this here. Boom, destroyed. So we know that our logic is working as intended. Now that we have that set up, we know that whenever it hits something, we're able to fire off any type of commands here. So now we need to make it so that we can spawn this projectile component on our first person character. So instead of going and creating an input map, mapping context for this, I'm just going to go ahead and just do a left mouse button. So it'll be a left mouse button down, and we're on the first person character here. And this is mainly just done for testing purposes. Normally you'd want to create an input action and map it to your input mapping context, but just for what we're doing here, this left mouse button is fine. We're just hard coding it to the left mouse button. So what we're going to want to do is we're going to want to say spawn actor from class. We're going to make some room. We're going to spawn our BP underscore projectile parent. We'll connect that up. Now our spawn transform, what we're going to want to get is we're going to want to get our actor location. And then we're going to want to get our forward vector. And then we'll want to multiply this by, we'll do a float. And we'll multiply this by, let's say, 50. And then we'll add these two values together. We'll split this struct. And we'll put that in there. We'll drag these up here. And then for these other values, we can leave our spawn scale at 0, or at 1, sorry. And for our rotation, we're just going to get our actor rotation. So that way, it'll always be facing the right direction. So one little note here, I was getting some weird funky behavior, because if you see here, if we click, it's looking this way, but if we turn, we can kind of see how it gets off-centered. And if we turn around and try and click, it doesn't work. And that's because we are using this get forward vector from a specific rotation. So what we really want is get actor forward vector. And so that's my fault. I apologize there. Now it should be working, always spawning in front of us. Yeah, there we go. See? And as soon as it collides with something, it will despawn. Perfect. So let's now set something up where we can be able to start adding our health components. So to set that up, I'm just going to come here to blueprints. I'm just going to create a new blueprint class here. I'm going to create just a character blueprint. I'm going to say CBP underscore. I'm going to just call this an enemy for now. Open this up. Under our static mesh, I'm just going to find our Quinn. And then for our anim blueprint, we're just going to come here and we're going to say ABP. Don't use this FP copy. It's going to look really weird. We want to say unarmed. And we are now all good and set up. So if we drag Quinn into the world and we turn her around, we hit play, we can see that she's there. And if we collide with her, our projectile collides with her, it destroys itself. So right now it's not set up to do anything. So normally what you might end up doing for a health system is that you would come into your event graph on your enemy and you'd create a few variables. So you'd create like, your current health, if I can spell. You make that a float. Then you'd create a max health. Right, and you'd set your values for that, and then you'd create maybe like a custom event that was damage, health, and you'd take your current health and build all of your code, and then from your projectile, you would then come into here, and instead of on destroy actor, you would cast to your enemy and call on that destroy or damage health. And then all of that ends up being baked into just this blueprint. But what if I want to use the same system on our first-person character? So if the character gets shot, well, then we'd have to go and we'd have to copy all of that. We'd have to come to our projectile. We'd have to then try and cast to our first-person character or use an interface. And it just starts to become really cumbersome. And then what if we want to be able to add that to what if we create another enemy type? And it's like, yeah, we might be able to use a parent and then it copies it over. But what if we have a completely new type of character? What if we wanted to be able to put it on an inanimate object? It just becomes really cumbersome and you're constantly repeating code and having to rewrite it. So how we get around doing that is we use actor components. So let's go ahead and build that first. So let's come into our actor component folder, which should have nothing in it. We'll right click, we'll say blueprint class, and then we'll select actor component. Now I use the naming convention AC for actor component, and that just makes it easily searchable when we have to find components or look for things. So here I'm going to call it just AC health component. I'm going to hit enter. So now when you open this up, it's going to look like a blueprint, but you're not going to have your viewport. So if you take a look at our enemy, we have our viewport, which shows us everything. Here we're just going to have our event graph. We're not even going to have a construction script because this is something that gets attached to, for instance, our enemy character. Now, from inside of this health component is what we will build what we had in our enemy. So instead of building our current health and max health into our enemy, we just build it into this component. So I'm going to create our variables. I'm going to say current health. Create this as a float. I will duplicate that, and instead of current health, I will call it max health. Compile and save. And let's just set some values for this. We'll say the max health is 100. We'll set the current health to 100, but in case we decide to change whatever our max health is, on our event begin play, we're just going to drag out our current health, and we're going to set it to our max health. So there's a couple other things that we want to be able to do here just so that we can protect ourselves and make sure that we have everything set up. And that's just going to be, once we set this, we're going to go ahead and say get owner. And then from our owner, we'll just promote this to a variable, and we'll just call this owning actor. And what this does is that whatever this ends up being attached to, it'll get this and we'll have a reference to it. So we can be able to drag off of this to reference what we might want to do to whatever is the owner, or we can use this to cast to a specific player or use it as an interface. And that just helps us have a reference to whatever our health component is attached to. One other thing we want to be able to do here is under this max health and current health, we just want to click these little eyes, and this just makes it instance editable, and we'll see why that's important here in just a minute. So now that we have this set up, we're going to want to create our logic that updates our current health. What we will do is come down here. Now, I like to use functions over custom events just because I feel functions are easier to keep track of. So I'm going to create a new function. I'm just going to call this function update health. And the reason I do that is because if instead of creating a damage health and a heal health, if I do update health, I can build all of my logic into here, and I only have to worry about one function. Since it's not too complicated, I feel comfortable doing that. If we're building a much more verbose health system, then separating them would definitely be a better call. But for right now, I think that this is fine. So what we want to do here on our input, we're just going to want to say, I'm just going to say incoming value. Create this as a float. And now what we're going to do is we're going to take our incoming value. We're going to subtract it from our current health. Like, for instance, if we wanted to heal, we would just have the incoming value be negative. So negative times a negative equals a positive. I don't know if you know the reference to that movie, but that's fine. And then we take this and then we just reset our current health to what our new one is. Then from here, we'll check this and we'll see if this is less than or equal to 0. Create a branch. If it is less than or equal to 0, we're going to grab our owning actor. And we're going to say destroy actor. Now, if we try to just say destroy actor without having our reference to our owning actor, we're not going to get that. We're going to get destroy component. And we don't want to destroy the component because that'll mean it will just destroy the health component. What we want to do is we want to destroy the actor. So that's why we grabbed a reference to our owning actor on our begin play, because that's what we want to do. So if it's less than 0, then we do that. Actually, we want to make this less than or equal to 0. If it's not less than or equal to 0, we're going to check our current health and see if it is greater than our max health. And if it's greater than our max health, well, we're just going to set our current health to our max health, so we don't ever exceed what our maximum is. And if it's not, we're just going to end our logic here. So if we wanted to, we could put a return node, but it's smart enough it'll automatically know what that is. So this is all of our logic here. Let's update our, we'll say print string. And let's do, just so that we can be able to see things, we'll do an append. And we'll say health equals, and then we will put our current health into here. And we'll plug this, and then if not, we'll just say that, and we'll drag our current health into here. And that way we're always getting our updated health. Right, so we've just created our logic for our component. Now what we need to do is we need to now get that available on our enemy. So in order to do that, we just come over here just like we would if we were to add how we add a new different type of component here, whether it's a mesh or, for instance, a projectile or a character movement. we just come over here and we do AC, which is why we look for AC. We have health component. And that puts it right under here. Now, Unreal has this bug. Sometimes this may show up in this area, up here with your other components that are actually selectable with widgets. If that's the case, you can just delete the beginning AC part. This will still be referenced as an AC health component. For whatever reason, there's a bug. Sometimes that happens. It puts it up there. So all we need to do is just delete the AC, and then that'll drop it down here with the health component. All right, so now we're not quite done yet. We're really close, though. Now what we want to do is we want to come over to our projectile parent. And instead of destroying the actor, before we destroy the actor, what we want to do is we want to damage whatever we hit. So if I were to come here and I say apply damage, and I hook this up, we can create a damage variable here. We'll just call that damage. Compile, save. Let's set this to, let's say, 25. And then for the damage actor, we just come here and drag off of this other actor. Now we come back to our CBP enemy. We come over here, we right click, and we say any damage. And we click on this here, that's event any damage. And this will be taking in whatever is being called from our projectile parent. We grab our health component, and we come here and we just say update health. And our damage, we just plug into our incoming value. Now there's a bunch of other things here that's like damage type, instigated by, the damage causer. We're not going to worry about that right now. We just want to be able to communicate to our enemy here. So then if I hit play, we come here, boom. Okay, I took a look at our logic here and we have this backwards. We want to subtract our incoming health by from our current health, not our current health by our incoming health. So we have our current health minus our incoming. So that was a mistake on my part. So now if we do this, we can see now health equals 75, health equals 50, 25, and once it hits 0, our actor is deleted. So we can see how from inside of our CBP enemy, we are calling upon our AC health component. So that is a great way of being able to use a component to manage a system. And that makes this completely modular. So now I can be able to add, for instance, this health component to our first person character. So I can come here and say AC underscore health component. See, here's where you can see that bug, how it pops up here. So all I have to do is just delete that, drops it down here. And then I can say the same thing by typing any damage, event any damage. I can drag my health component out and then say update health. And now our player can be able to receive the same thing. And I didn't have to repeat any code. All I'm doing is just grabbing my component and calling on my update. So that's one way of being able to use actor components, and that builds a system into your game that's very easily scalable. Another thing that we can be able to do is actor components don't need to necessarily be called from inside of its parent. So let's take a look at that. So if I come over here, I'm going to come back and say blueprint class. I'm going to say actor component, and this time I'm going to say AC underscore line trace. And this is just going to create a trace to be able to see what's in front of us and get the name of whatever it is. So maybe we want to interact with it. Maybe we want to pick it up. Maybe we want to see the item details on that particular thing to be displayed on our HUD. And this is all going to be managed from just within our line trace. So I open up our line trace. And from in here, we're going to do the same thing that we did before. We're going to want to get our owner, because we always want to make sure we have a reference to our owner, promote that to a variable. We're going to call this owning actor. So that way we can always be able to reference our parent and be able to, like I said, cast, do any type of blueprint interface, destroy it, and do anything that we need to so that we have that reference to it. On our event tick, this is what we are going to do. We're going to say align trace by channel. And we're going to plug this into our event tick. Now to get our start location and our end location, this is where having our owner is important because we need to access a few things from our owner. So we need to access, for instance, the camera so that we can get the camera location and know how far from the camera we want to be able to draw our line trace. So from our owning actor, I'm going to drag off, I'm going to say get component by class. Make sure it's not components, plural, make sure it's singular, component by class. And from here, we're just going to look for a camera component. Now, I could just drag off, turn this into a variable and set it, but if it doesn't have a camera component, we want to make sure that we don't have any errors. So what I'm going to do first, I'm going to drag off here, I'm going to say is valid. I'm going to do this question mark. So if it has a camera component, then we're going to set it. If it doesn't, I'm going to do a print string. And I'm going to move this down just so we have a little bit more room. And I'll do an append. And I'll put this in all caps and I'll say camera component not found on, and then a space. And then we'll grab our owning actor and plug that in right here. And this will let us know if there is no camera component, then we will get this error. And let's make it red so it's hard to miss. And we'll set it for 10 seconds. And I'll show this off here in just a second, but this is just to help notify us if there's anything that's wrong. So if it is valid, we grab our camera. So from this spot, what we do is we get our camera, we get its location, so we'll want to get its world location, and we set that to our start. And then from here, we will say get forward vector. We'll multiply this by a float, and we'll do 300. Then we'll drag off of our world location, and we'll add these two together, and then have that be our end. So we're getting the location, we're looking forward 300 units, and that's where it's going to end, and where we start is the location of wherever the camera is. We are ignoring ourselves. We'll set the debug time to a duration, and we'll set this to, we'll just do 0.2 is what we'll do. So that way it shows up for just a little bit. Now, we're drawing this trace. And what we want to do now is when we hit something, we want to be able to display the name of whatever it is that we're hitting. So in order to do that, you can drag off this and say break, and that creates this node. Personally, I like to just say split struct pin from here. Not everybody likes to do that. Sometimes I'll use a break node. It just depends on my organization and what's easier to see at the time. This to me feels just nicer because it keeps it all contained in one node. So I'm not going to worry too much about that right now. For this, I think it's fine. So if we do hit something, we're just going to hold B for our branch. If we do hit something, what we want to do is we're going to grab our out hit actor, and we're going to print whatever the name of that is. So we grab our out hit actor, we'll drag that in here. And then for this, we'll just set this to 0.01. So it only displays for a fraction of a second, but as long as we're hitting something, it'll be there. All right, so Now that we have that all set up, this is again all self-contained. If we come to our first person character, we click add, we go AC underscore. We see our line trace here. Again, we have that little bug, so let's delete that so it shows up down here. You can see how it moved the character movement component up. So it's just a visual bug. It's not going to change anything. You can't grab any widget from it. There's nothing there. If it's up here, it'll generate one, but there's nothing that you can do with it. So now that this has been attached to our first person character, if I go ahead and hit play, you can see we have our line trace. And whatever we collide with, we see we have floor, we have small cube 2, we have our cylinder 8, we have our small ramp, our quarter cylinder 2. So now we can see that everything that we are colliding with is there. And that is a actor component being completely self-contained, because we're not calling that at all. So the actor component can be able to do its own thing and run its own code completely separate from having to be called within its parent. And that makes this really nice, because now you can be able to add this to, let's say you create another character that's not based off of your first person character. You can add that and everything is just going to work. You're going to always have your line trace. And if you want to make these, you can make these variables public. So if you wanted to turn this into a variable, this can be adjusted. So let's go ahead and do that. We'll say line length. You can see on our line trace, I have this line length. So if I wanted to make this shorter, I can set this to 100. And now when I play, it doesn't go as far. Do that. Or if I wanted to make it go incredibly far, I could set this to 500, and I should be able to, reach the wall from here. And that'll be all self-contained within its own code, which makes it super versatile and super nice and easily scalable. Now, there's one more thing I want to be able to take a look at that can show you how even more versatile this can end up being. So right now on our enemy and on our player, when we get hit, we're pulling from the health component and saying update health, which works fine. But what if we want to add this health component to, let's say, a wall? Because you can be able to do that. So let's say we take this big old wall right here, and we come over, we can see on this right side how we have cube, and we say health component, and we drop it in, and now it has this health component. We can set our values, and we go and shoot it. Nothing happens. And that's because we're having to call our update health from within the blueprint that it is. But this isn't a blueprint, but we want it to have a health component, because let's say we want to be able to shoot a wall and then the wall be destroyed, but we don't want to make it a whole on blueprint, because it's just not going to make too much sense to have one blueprint for just the ability to destroy a wall with health. So here's what we're going to actually do. Under our projectile parent, right now we're applying damage, and we're applying damage to the damaged actor. What we want to do instead is on collision, we're going to disconnect these for right now. We're going to drag this out. And when we collide with something, we're going to say get component by class. So if I do AC underscore health component, I'll then run another is valid. If it's not valid, we just want to destroy the actor. If it is valid, instead of applying damage, we're going to drag off of this, and we're just going to say update health. And the health that we're going to update is going to be our damage. And then if we come in here, we can now say destroy actor. So now what we're doing is that we're calling this function from inside our projectile. And then for our target here, we just want to say other actor. So we're checking the other actor to see if the other actor has a health component. If it does, we're updating health with whatever the damage is. Then we destroy ourselves. If not, we just destroy ourselves. So if I come over here now, I can now actually completely delete this, compile, save. Same thing with the first person character, compile and save. And when I shoot our actor, we get the exact same result. But now that our wall, which we put our health component on before, has it, even though this is not a blueprint, if I hit play and I shoot the wall, 2, 3, 4, boom, our wall disappears. So that allows our health component to be incredibly versatile, and we can place this on whatever other objects that we want to, even if they're not blueprints. You have to select the object first and then drag it over here. So like if I want to do it on this ramp now, if I shoot this here, nothing happens. But if I shoot it on our ramp, it disappears. That allows our health component to be incredibly versatile and scalable and allows us to be able to apply it to many other things. And just to show off the whole line trace situation, I'll grab this cube right here and I'll attach the line trace component to it. So remember, we had set up to where if it doesn't have a camera, it says, hey, this doesn't exist on whatever the owning actor is. So if I go ahead and hit play now, we'll see this error message. Camera component not found on small quarter cylinder 2. And then it doesn't create the line trace. One of the things I forgot to do here is we just want to do another is valid off of the camera. Because if we don't have a camera, then we don't want to do a line trace. Otherwise, if we put it on something that does, it's still going to try and do the line trace, but it's going to throw some errors. So now if I hit play, we'll get that error. We come over here, right? It's not found on the small quarter cylinder 2. And if I exit out, our errors are now gone. So that is a quick explanation and demonstration of actor components. I hope you found this helpful. Please like, comment, and subscribe to the channel if you like this. Subscribing really helps grow this channel. It also gives you any updates whenever we release any new tutorials or reviews. If you made it this far in the video, leave a comment down below telling me your thoughts on actor components, if you've used them before, if you didn't know about them, or if you have any questions about any other applications that they could be used on or for. I'd love to be able to hear your thoughts, comments, and questions. So thank you so much. I really do appreciate you guys for watching this video. I hope this helps you out in your game dev journey. That's going to wrap it on up. So as always, I appreciate you. Happy developing.